So this lecture is going to go over a little more advanced algebra. We're going to do some solving in terms of multiple variables down here on this page. And then we're also going to look at this worksheet right here where we do the same thing, but we use some variables that are more specific to physics. So we're going to be using a lot of our same algebra rules, but let's see an example, right? So I think questions 1, 2, 3, and 4 are like the ones we did before. Make sure here you multiply by 3x plus 4 together here to move that off the bottom. And let's go ahead and start with number 5 here. So number 5 is probably the toughest problem on this worksheet. And so if we can handle this one, then we're going to be good to go on the other ones. So number 5 says b is equal to negative 2 times x minus a divided by 3 plus c. So in a problem like this, we just want to know what x is in terms of b and a and c, because we don't know what those variables are. But so really we're just getting x alone, right? We're going to push all the other variables to one side and then solve for x. And so there's multiple ways to do this. I think one key here is that I'm just going to pick one way, and our answers at the end should look, they're going to definitely be equal, but they might not look identical. So if you pick a different way, you might look a little different at the end, but it'll still be identical, because this is math and we deal with equalities here. So we're going to get x alone, and x is definitely equal to something in terms of a, b, and c. All right, so to start with here, I can go ahead and pick what to do. We can multiply by 3, or we can distribute this 2, or we can even get rid of the c, right, and kick it over to the other side. I kind of don't like it hanging out there, so I think that's probably the first thing we should do. So we'll go ahead and subtract c from both sides, right? So we're going to end up with b minus c is equal to negative 2 times x minus a over 3. All right, now we could deal with this negative 2/3 together. If we did that, we'd have to multiply both sides by the reciprocal and also negative, so that would turn it into a positive 1. So I'd have to multiply both sides by negative 3 over 2. Just to maybe keep it a little easier, though, I'm just going to go ahead and multiply just by 3. So if I just multiply by 3, that cancels this 3 and puts a 3 right here times b minus c. Now you could distribute that through and you could have wrote 3b minus 3c. I'm not too worried about that, right? We're just trying to get an expression here for x. So I'm going to go ahead and rewrite so we can see what we're looking at. And this is also a good idea of the kind of work I would expect on a test, or the work I would expect you to show to earn credit. Because on a test, if you don't show your work, you don't get any credit. For all I know, you could have just copied off somebody else. All right, so then we're going to divide by negative 2, right? So just gradually getting this alone. Get rid of that negative sign, right? We don't want that there. So cancel the negative and the 2. Divide this side by negative 2. And so let's see what I have, that negative 3/2. That's what we could have multiplied both sides by, but whatever. So I'm gonna go ahead and rewrite this. I'm gonna go ahead and put the negative sign out front. Negative 3 over 2 and times b minus c is equal to x minus a. All right, so we just have one last thing left to do, and that is to multiply, or not multiply, but we got a subtraction here. I want to get x alone, so we're going to add a to both sides. So when we do that, when we add a here, we're going to go ahead and cancel this, and we'll be left with x all alone. I'm going to go ahead and put the x on this side because I can do that. Negative 3/2 is equal, because it's an equality, right? So it doesn't matter what side what's on what side. Negative 3 times b minus c, or negative 3/2 times b minus c is plus a, right, is equal to x. So I also could have written that just slightly differently. And that's fine too. But this negative 3/2 is not multiplied by the a. You could distribute it through both of these. In that case, you would get negative 3/2 b plus 3/2 c plus a, and that would also be correct. So, oops, you couldn't see that. Sorry about that. I'll go ahead and rewrite that one more time. So all of these are technically right. So I'm going to go ahead and put a box around that one. Another way it could have been written then is negative 3/2 b plus 3/2 c plus a. And that would work too. So any of those three ways is fine. And yeah, so there's your answer right there. Okay, let's go ahead and look at another problem. So, might as well do number 7 here also, right? Why not? So 7 says, I don't think this one's going to be tough, but I feel like we should do a second one. Oh, and by the way, this is just a mistake I made. I should have probably used some whiteout or something, but yes, that's nothing there. Ignore that. So it's just negative 31 over x plus b equals c. And there can go ahead and be a parenthesis around this. That's fine. I know some of your kids think that that's something. I don't know what they think it is, but they they're confused about it. So yeah, don't be. All right, so let's look at number 7 here. So I'm going to go ahead and rewrite it. I'm just going to, this is just 2 times b. I'm not sure why there's I could just wrote 2b. Okay, so this plus d is outside of the fraction, right? All right, so I'm thinking same thing as before. Let's get this d over here by the b, and then we can deal with the x there. All right, so we're going to subtract d from both sides. So we're saying b minus d is equal to 2b over x minus a. Now something you might say here, do the b's have to be simplified? I think we're going to end up with b in 2 places here. No, it's not necessary for this class. What we're trying to do is just trying to get at this variable x in terms of the other variables. Would it be nice if b was only written in one place? Sure. Yeah, like math class, yeah, definitely. All right, so this x minus a is together, and we're going to multiply both sides by x minus a. I think you can see where this is going. Ugh. So this looks like fun, right? This is where we'd have to multiply x times b, and then negative a times negative d, and then negative a times b plus negative d times x. We're not doing all that, right? This isn't math class. So what we can do then is just divide, right? Let me rewrite this one more time. Let's just kick this now, right, back over there. We don't want this here. We want x. We had to just get x off the bottom. That's why we did that. So now x is on top. We got to get it alone. So let's divide by this expression right here. So I'm saying we're going to divide this by b minus d. And you got to do it to this side if you do it to that side. All right, so we end up getting that. And then we can go ahead and add a to both sides, right? Show my work. So we're saying x then is equal to 2b over b minus d. I'll go ahead and put the parenthesis around it, plus a. All right, good deal. All right, hopefully there's no questions there now, and that's making more sense. I know it's confusing for students not working with numbers, but it's good practice. All right. They actually will ask questions sometimes on the AP Physics test to solve in terms of the other variables. And so you're doing math with letters like this. And yeah, it's a good time. All right. Let's go ahead and go to this page now. So here we're seeing it with some actual formulas. Something that's tricky about physics is we sometimes one variable, like the letter x, will be represented by two letters. So this is Ke, or kinetic energy. So that's just one variable. This is m for mass, v for velocity. This is h for height. This is Pe, or potential energy, right, is equal to m for mass, g for the Earth's gravitational field, height, the height of the object. Down here, r is not the radius, actually. It's the distance from the center to center of two objects. So I want to say that I picked, this is the mass of the Earth and the mass of the sun, that you're solving for the distance center to center of the Earth and the sun. So I'm saying that you have the Earth here, and it's going to be m1, and you have the sun somewhere out here. This is not drawn to scale. The sun is much larger than the Earth. So I'm saying that the distance from the center of the Earth to the center of the sun, right, is equal to r. And so here we're going to solve for r in terms of the other variables. Then down here we're going to plug in these numbers and get a number for r. So let's get started at the top, right? So solve for v here in terms of the other variables. So I have our kinetic energy formula, Ke equals 1/2 mv squared. We have to get v alone and then deal with this exponent. We have a half out front, so the way I like to deal with a fraction out front is to multiply both sides by 2. It's 2 times half, 2 halves is a whole, or 2 over 2 is 1. So this ends up canceling that, but if you do that to that side, you got to multiply this side by 2, because this is an equality, right? That's what the equal sign means. So we get 2 Ke is equal to mv squared. We'll then divide both sides by m. All right, simple enough. We'll then be left with v squared is equal to 2 Ke over m. What do we do now? Well, we got this squaring here, and this is something that has to be dealt with, so we cannot leave it there that way. So we're going to square root both sides. So when we do that, we're going to square root v squared, and we'll get v is equal to the square root of 2 Ke over m. All right, pretty good. So that's it. Hopefully there's no questions there. One thing that I guess I would say is that with this, right, this bar here looks like the square root sign, right, looks a lot like the v. So when we write the v for velocity, we put this little tail out in front, and that's something just to notice. Sometimes when we square root things, we get a positive or negative as well, and sometimes we have to throw one of those answers out because only one of them works or makes sense. Here we're not really worried about that. We're just going to write v equals the square root of 2 Ke over m. All right, so there we go. Let's look at problem number 2. So now that was the kinetic energy formula. Now let's use the potential energy formula. So in number 2, we have Pe is equal to mgh. Let's solve for h, right? Pretty simple here. We could divide by m and then divide by g, but why don't we just divide by both at the same time, right? Why not? We can do that. We're showing our work. So if we do that to that side, we got to do that to this side. So we get then h for height is equal to the potential energy divided by mg. I don't expect you to know what any of those letters mean, but I do expect you to be able to move variables, and eventually we will learn what these letters mean. But you know, the skill we're working on right here is just manipulating formulas. All right, number 3. This one's going to be a little tougher, right? So I was going to use the back of the page. You know, why not? I feel like I've been wasting a lot of paper when I don't use the back of these pages. So number 3, is our universal gravitational formula. So this says that there's a force of gravity between any two masses. All right, so let's go ahead and write the formula, right? First of all, we have something Fg here. This means the force, and this is a subscript. So this is like an adjective in English class. So this just describes whatever this is. So this means the force of gravity. But instead of writing gravity, I just write baby G there. All right, it's just much easier. But you could write the word, you could write F and then gravity here if you really wanted to. It's just a lot to write. So Fg is equal to G, which is a really tiny number, and it's the universal gravitational constant times m1 or mass 1 times m2 divided by r, which is not the radius, right, but the distance from center to center squared. All right, so there's our formula right there. Okay, so we got to solve for r. So we got our variables on the bottom, right? Let's get it off the bottom. So we'll multiply both sides by r squared. That's probably the first thing we want to do, right? And this r squared is on top of the fraction. So, and we'll multiply this side by r squared. All right, I'll go ahead and rewrite them. R squared times Fg is equal to big G, m1, m2. Now, let's get Fg over to this side, right? And so we're left with r squared over here. How are we going to do that? I should probably show my work. I forgot to. Divide both sides by Fg, right? And that will cancel that just like that, and we'll send it over here. So now I'll go ahead and rewrite. R squared is equal to G m1 m2 over Fg. Then what's the last step? Well, just like with the KE formula, we'll square root both sides. So we'll square root here and square root here, and then we'll go ahead and write it out. R is equal to the square root of G m1 m2 divided by Fg. All right, there we go, and that's it. So now we have a formula we can use to solve for the distance from the center of the Earth to the center of the Sun, right? And but when we use it, we have to be very particular with our units. For instance, the units on M have to be in kilograms for both of these, and the units on Fg have to be in newtons, and your answer is going to be in meters. And you have to remember that there's 1,609 meters in 1 mile. And we'll talk about conversion factors soon enough. So if you're wondering, you know, well, how many miles is it when you get your final answer, that's what you're going to do. So I'm going to rewrite this with some numbers in here. So I'm going to say then, and I'm given numbers at the bottom of my sheet, right? Ugh, you know, kind of gross to look at. This one, when you look at this, right, this says G is equal to 6.67 times 10 to the negative 11th. First of all, this meters cubed divided by kilograms times seconds squared, we can just ignore right now. That's just units, to be honest. So we don't have to worry about that. So all we need out of this G equals is what this is, right here. Right there, that's all we need. So we're going to use this. We can ignore the kilograms, and newtons. As long as they're in the right unit, we're good, because that's the only way the formula will work. I'm not going to write them right now, because my rule on writing units is I always write them, except when the numbers get kind of crazy and there's not enough space or it's super confusing. So in this case, writing these units, meters cubed over kilograms times seconds squared, is super confusing. And I could write kilograms, and newtons, but I'm just going to choose not to right now, because I just want to make it as simple as possible. So let's see what that looks like, right? So I'm saying then R is equal to the square root, see if I can get all this on here, 6.67. This is a very tiny number for big G. It's a capital letter, but it's a super tiny number, right? That's what the negative means. We'll talk about exponents here shortly, and how to move our decimal point. Times the first mass, which is the mass of the Earth, which is 5.972 times 10 to the 24th. Not a fun number. So this is a very large number. The reason I know that is this is a positive exponent. Negative exponent is a very small number. This square root sign's got to extend further. Oh, ignore that up there. And this is going to be 1.989 times 10 to the 30th. And then we're going to divide that all by FG, which is 3.51 times 10 to the 22nd. All right, and notice the mass of the sun is larger because of this 30 here. 6 powers of 10 larger, so 10 times 10 times 10 times 10 times 10 times 10, right? Larger. Without even looking at the 5 and the 1. All right, and we're going to divide here. So this is a job for our calculators, and I kind of put this on here as a challenge just to see if you knew how to use your calculator. So what I'm going to do is I'm going to multiply these three. I'm going to do it slowly so I don't make any calculator mistakes. Then I'm going to rewrite this as a number, divide this number by this number, then at the last step I'll square root. All right, so what does that look like? Well, hopefully you can see this. I know there's a little bit of a glare. Maybe that's the best right there. I'm going to go ahead and start with, let me see. Oh, that didn't help. The green screen here. I'm going to start by getting rid of that parenthesis, and then write my 6.67. All right, something you want to use if you have the calculator for it is a times 10 to the, EE button. This is something exponent, and I can't remember what it is. Students always look it up for me and tell me every year, and then I always forget and ask them to look it up again the next year. 6.67 times 10 to the, and this is the negative sign down here. This is subtraction, so you have to use the negative sign. Negative 11. And I get something that looks like that. 6.67 E negative 11. And this, in case you want to check, you can always type it in and then hit enter. Sometimes it'll pop up as 0.0000000, so on, and then 667. But my calculators won't do that. Some do, some don't. It's fine. All right, so then I'm going to multiply that, use another parenthesis just so I don't screw this up. 5.972 EE, that means times 10 to the 24, end parenthesis, right? So these are being multiplied as evidenced by that asterisk there, which you can barely see. And my number got smaller because this was a negative exponent and this is a positive exponent. I think when you multiply them, you end up adding them together, right? So, all right, so there we are. All right, then we're going to multiply one more time by the mass of the sun. So times parenthesis 1.989. Hopefully you can see that, times 10 to the 30th, end parenthesis. And now it's 7.9228 31436 times 10 to the 44th. Now, I'm going to rewrite that really quick, but something you don't want to do is you really don't want to round till you're done with the problem. So I'm just going to round on here, but I'm not going to round in my calculator. I'm going to leave all those digits in there. But if I, or I guess I can write them. I won't be lazy. 7.922831436 times 10 to the 44th. Now you would never really write all those on a test, right? You would round to have 2 decimal places or 3, or if you know chemistry, because maybe some of you are enrolled in AP Chem, you would use sig figs, which means you can only keep as many numbers as your worst number, right? You're only as accurate as your worst number, right? Your team's only as good as your worst player, something like that, right? And or you only can measure as well in science as your worst instrument. All right, so here we are. This giant number on top. We got another giant number on bottom. We're gonna have to divide. When we divide, we're gonna subtract these exponents. So my guess is this is gonna be whatever this number is, gonna be around times 10 to the 22nd. So I'm gonna go ahead and type that in the calculator. Let me see if you can see that. Divided by parenthesis again, right? Let's not screw this up. 3.51 EE times 10 to the 22nd, end parenthesis, enter. Look at that. We got it down to times 10 to the 22nd, and it's 2.2572169. Now, that number times 10 to the 22nd is under this square root bar. That is the number right here. So I have one last thing to do, right, which is the square root. So I'm saying that this, which I'm running out of room, is equal to the square root of 2.257, right? I'll just write that out right now, times 10. Oh, this is hard to see. I'm running out of room. Times 10 to the 22nd, right? That's equal to that. And so I have to square root this, all right? And then I'll get my answer. So let's go ahead and do the square rooting, right? So answer's right there. With these scientific calculators, one nice thing is you can hit, find my square root bar. I guess I could just raise it to the 1/2 power, but I have a square root sign right there. So I'm gonna hit second square root. All right, there, I got it. And then I'm gonna hit parenthesis. I guess I didn't need to do that, but I'm gonna hit second answer. Otherwise, I gotta type this in, times 10 to the 22nd. So I'm gonna hit second answer, and then it just says ANS. So that's the answer, end parenthesis. And so it's gonna square root that answer for me. All right, and when we do that, we get a large number with no scientific notation. That's a bummer. Let's see what that is then, because I'll just write it out on the piece of paper. 15024071849. All right, comma, comma, comma. And this is in meters, right? Remember what we said, it's in meters. So, all right, so this would be thousands, this would be millions, this would be billions. So this is 150 billion meters. Okay, all right, that's good. How else could this have shown up in your calculator? It might have showed up as, check this out, right? Let's take our decimal there, put it there, and then let's make some moves with it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right there. So if we move it 11 times, it would also be written in your calculator as 1.502 roughly times 10 to the 11th meters. And this is how far the Earth is from the sun, center to center. Anything else I wanted to add to that? I don't think so. Other than is if you wanted to convert it to miles, we said that 1 mile is equal to 1,609 meters. So if we just did the conversion factor there, which I'm going to talk about in future lessons, right? It would equal, divide that by 1,609. So I'm saying that the center of the Earth from the center of the sun is 93374 .998 miles, right? So what would that be? Well, looks like 93, would that be a million? 93 million miles. So we're saying here the center of the Earth to the center of the Sun is about 93.4 million miles, or 9 times 10 to the 9.33 times 10 to the 7th miles. Right, any of those would work. So you can Google that and check that. Check it on your phone and see if that's right. All right, that's it. Have a good day.